Welcome to part 4 of the Dueling AI series, where we're working on a self-play architecture with a custom Pong engine. Where we left off in the last video is we have our Pong game mostly playable, but it's me as a human currently controlling both paddles with my keyboard, which is a fun little challenge, but not really what we're trying to do here. So in this video, we're going to go ahead and implement a bot player. So this will be a statically coded bot that later on we can use to score the AI. You know, if you're training an agent against itself, you need some ability to have a yardstick to measure its performance against. So in this video, we're going to go ahead and work on that yardstick, work on that bot player. And we're also going to implement the game over dynamics and a little bit of some of the reward capabilities. So we're going to be trying to really round out the game in this video so that we can hopefully in the next video go ahead and start working on some of that agent functionality. So let's go ahead and start with a getBotMove function. So getBotMove is going to be part of the Pong game function. And it's going to be getBotMove self, and we'll pass in player. And we want some degree of randomness. So it's actually pretty easy to code a bot that is really, really difficult to play against. You just make it track the ball. But you want some randomness so that when you're, you know, playing against your perfect ball tracking bot, it needs to occasionally make a bad move, or it's really, really hard to score against it. Other games are probably a lot harder to make a perfect AI player or a perfect bot player, but this one, pretty easy. So we want a little bit of randomness. So our random target is going to be 0.1. We're going to set next move to 0. We are going to grab the player Y. So existing player Y is self.player1 paddle.y if player is 1, else self.player2 paddle.y. All right, and then we're going to have different bot difficulties. So we're going to start with if self.bot difficulty equals easy. We're going to say if random.random is less than or equal to random.random target, then next move is random.rand int 0, 2. So just a random number between 0 and 2. Else, if self.ball.vy is greater than 0, next move equals 2. Else, next move equals 1. It'd help if I actually put this down. And then finally, at the end here, return next move. All right. So what this logic's going to do is it's going to track the direction of the ball, and it's going to move the paddle in that direction. What you'll notice, and the reason this is the easy bot, is it's not actually taking any account of where the ball is in relation to the paddle. So it doesn't know if the paddle's already higher than the ball. It just knows ball goes up, paddle goes up. So it's playing like a very reactive player, like somebody who is just like, oh, I see the ball bouncing towards the top, I'm going to shoot the paddle to the top. That's basically what our easy difficulty bot is going to do. So let's go ahead and implement our get bot move. And we're going to implement it in a couple of ways and places. And the reason you're going to see some duplication here, and some of why you're seeing duplication, is that we are going to run into some issues, or not issues. We're going to be using the game loop when we as humans are playing the game. But we're not going to be using the game loop when the AI is training on the game. The game loop is purely for the human playing. So we're going to need some safeties in step, as well as some intentional logic in the game loop itself. So let's start by going down to step. So here's our step method. And what we're going to do here is we're going to say if player one action is, and this is where we actually need to change this from 0 to none. So we're going to say if player one action is none, then player one action is equal to self dot get bot move with a player one. If player two, and I'm intentionally not using an elif because we could have either or both not have a move. If player two action is none, then player one action or player two action is equal to self dot get bot move 2. All right, so that's a safety. That's just there to catch things that we weren't expecting. Let's go ahead and head up to our game loop. Okay, so right around here, where we're checking to see if players are human, we want to go ahead and first off, we can go ahead and delete these. We don't need these prints anymore. They are not necessary. So we need to say if self.player1 is equal to bot, then player one action is self.get bot move player equals 1. If self.player2, actually, let's just copy. So if self.player2 is equal to bot, not player 22, player 2, then player 2 action is going to be self.bot move player 2. All right, so at this point, what we should be able to do is go over to our main.py, and I am just going to comment out that first one. We'll make switching back and forth between them a little bit easier. So I'm going to say player 1 is human, player 2 is bot, and bot difficulty is easy. All right, so at this point, I am playing the green paddle, and my easy bot is playing the purple paddle. And you can see it really is an easy bot. It kind of moves in the general direction that the ball is moving. And sometimes that's okay. You can see it just caught one. But it's not the best logic. It is exactly what you would expect from an easy bot. So what I'm going to recommend is this is a great time to pause the video and challenge yourself a little bit. So we just created an easy bot in game.py. I am going to challenge you to go and build yourself a hard bot or do an intermediate bot. If you'd rather watch me build the hard bot and then you do like a medium bot, that's fine too. But I'm going to say pause now, go build yourself a hard bot, and then come back to the video and see how I do it when you're done. All right. I'm going to assume that the people who wanted to pause have done so and have built their hard bot. Let's go ahead and build our own hard bot. All right, we're going to do elif self.bot difficulty is equal to hard. So we're still going to do our random target logic. So we still want a tiny bit of randomness. We want about 10% randomness. Else, if self.ball.y is greater than player y plus 60, that's for 60 pixels. Next move equals 2. Elif self.ball.y less than player. All right, less than player y plus 60. Then next move is equal to 1. And this is pretty simple logic, but basically what it's going to do is track the ball perfectly, except for that 10% of the time. And it will look a little bit erratic, but it'll also play very, very well. So let's go ahead and come back over to our main.py, and I'm going to do another copy paste. And this time I'm going to say bot difficulty hard. Oh, that did not. There's definitely something broken. I have a typo somewhere. Hang on. Let's go over to our game.py and figure out what I messed up. So self.bot difficulty, random target. Yep, next move, random target's pretty low. Here, this is supposed to be a greater than. I had both less thans, which was not what was intentional. All right. Again, you can see a little jittery, but my hard bot hits basically every time. It is really hard to score against it because it's tracking. And it does occasionally mess up. You can get a score in sometimes during that 10% randomness, but it's hard to do. So we've successfully written a static hard bot that is capable of beating me pretty easily, especially when I'm distracted and trying to talk and play. But I will not win against the hard bot in general, which makes it a really good yardstick to train our AI against. So let me pull up our training graphs here. Give me a moment. All right, so I showed these training graphs in the first video. And what I did here is I played the first 350 episodes against the easy bot because, you know, after that point, the agent just wins all the time and it doesn't really give us anything interesting. It's just time. And then I started playing against the hard bot, which you can see we never really get a score of above about 3. But now that you've seen the hard bot and you see that it's pretty accurate, it's going to track the ball. So let's talk about its accuracy level for a moment and what a score of 3 means in this context. 3 to 4, an average score of 3. So the hard bot, if we're doing something random 10% of the time and we're tracking the ball perfectly 90% of the time, you also have to assume that out of that 10%, about half are going to be the right move in any given time. So let's say that we're 95% making the right moves with the hard bot. We are only playing 2,000 steps in our training runs here. So what that's basically saying is that inside of 2,000 steps, we are able to score, 3 to 4 against a bot that only ever misses or only does the wrong thing, not necessarily misses, 5% of the time. So the scores that we're going to get later in the course, later in the video series, against that hard bot are actually incredibly good. It may not look like a lot. Again, hitting 3, it's not super satisfying. It's not like watching it hit 20. But it is a really good response from what we're going to have here. All right, let's go ahead, and we need some game over logic, because so far we can basically just play forever, which is less than ideal. So we're going to go ahead and do a game over down here. So def game over self, and we're going to say if self.player1 score is greater than or equal to self.topscore, then we're going to create a game over surface that's self.announcement font.render player1 true. Still don't remember what that true is. And self.player1 color. And actually, we'll just wait. And then I'm going to copy this whole thing and do the same thing with player2 score. Two, 1. Self.player2 color. All right. And then we will do a game over rect is equal to game over surface dot get rect center equals self.window width divided by 2 and self.window height divided by 2. And we're doing the double slash to get an int out of that, if I recall correctly. It's been a little while since I've touched that. And I realized looking at this that I have one of the parentheses in the wrong place. There we go. That's what we want. We're going to do self.screen.blit game over surface, game over rect, pygame.display.flip, self.done will be true, time.sleep 10, just to give you time to see the message. And then we'll do pygame.quit and sys.exit. All right. And we need to go to the top and import time. All right, we've successfully imported time. We've got our game over screen. Let's go down to our step function. Get rid of that. All right, so we're in our step function here. We are going to say that if, we need a couple of checks here. So if self.player1 score is greater than or equal to self.topscore, or self.player2 score is greater than or equal to self.topscore, And by the way, if it feels like we're duplicating logic, we are a little bit. And it is, again, because there's more than just human players. So we need a couple of checks. That'll be a little bit of a theme here. So we're going to say if self.render mode is human, then self.gameover. Else, we're just going to set done to true and truncated to true. All right. And just for speed here, we're going to set top score to 10. We'll come back and change that later, but I just want to be able to test this real quick. So I'm just going to not fight back against the agent. I'm going to let it score 10 quickly. All right, so we get a player 2-1. This is a good place to go ahead to, and it's going to pause for 10 seconds, and then it should close. All right, cool. That's what we expect. Let's also go and test out let's test player 1 as a bot and player 2 as a human. So this is where I'm going to take over as the purple paddle, and our bot is going to take over as the green paddle. And it's worth mentioning, like, take the time now to make sure all of this works really well. Play as both players as a human, play as both players as a bot, like make sure that it's all very, very functional. Otherwise, what you're going to run into problems later on. You don't want to be troubleshooting the game when what you're trying to fix is your AI agent. You would rather just be able to focus on your agent. So if you see any weird behavior while you're in this phase, now is the time to stop and go fix it. And as a reminder, the GitHub links for each section of the video series are in the video description. So if you hit a point where you've got a bug, you haven't been able to solve it, take some time, go look at the code base, hop on the Discord, ask ChatGPT, whatever your preferred troubleshooting method is, and try to get things working really, really smoothly up to this point. All right, we are now going to go ahead and work on our observations. So this is the first point where we're really going from something that is a game to something that is intended to be a reinforcement learning environment. So we're going to go ahead up under reset, and we're going to do a def get obs, and this is going to pull an image observation from our environment. So we're going to be training on images. We're going to pull back an 84 by 84 grayscale image from the environment for the AI to learn to play with. So screen array is going to be pygame.surf.array.pixels3d self.screen, and screen array is going to be where we need to change the dimensions a little bit, or not dimensions, the channels. np.transpose screen array, and then we're going to do 1, 0, 2. We're going to resize to 84 by 84. So we're going to say downscaled image is equal to CV2. And we do not have CV2 yet. We have not yet imported it. So let's just go to the top and import CV2. We'll also go ahead and import numpy as np and import torch, because those are all things that we will likely need as we're getting into our get obs. All right, downscaled image, cv2 dot resize, screen array, 84 by 84, interpolation, and we're going to do cv2 dot inner nearest. So at that point, we should have an 84 by 84 image. Then we're going to do grayscale is cv2 dot cbt color, downscaled image, cv2 dot color, RGB to gray. And then finally, instead of just straight grayscale, we are actually, and this is another, so let's talk strategy for a moment. When we get into self-play, there are a few different ways that you can handle this. You can handle self-play in an environment by trying to do some kind of player channel to tell an agent what side it's playing on. You can also, for games like Pong, just flip the observations. So you can flip your observation during action selection so that, you know, the agent always thinks it's playing on the same side. So if you think about it, it's a symmetric board. If we train the agent to be on the right side, then when it's playing on the left side, we just flip the observation and it always thinks it's on the right side. The one thing that throws, or one of the things that can throw that off, is that our paddles are different colors. And even when even when you do a grayscale, like the grayscale of purple is still different than the grayscale of green. And it can throw training off and make it more complicated. So what we're going to do is we're going to say grayscale, where grayscale is not equal to 0, set it to 255. So we're basically going to force this thing to only have black and white as its colors. We're doing color RGB to gray. That gets us from 3 channels down to 1 channel of grayscale, and then we're taking that everything is either a 0 or a 255, and giving the agent a very simple black and white image to learn from. So we'll see the game in color. It'll see it in solid black and white. Finally, we're going to do observation is equal to torch dot from numpy grayscale dot float dot unsqueeze to add a dimension we need there. And then we're going to return observation. So now we have a successful get obs. We're really, really close to just being able to, start to work on some AI here. We need to go ahead inside of our step method, and let's go find step. All right, so down inside of our step method, towards the end, actually, let's see, where do we want to put this? We want, right after our step repeat, we want to go ahead and do observation equals self dot get obs. Okay. And you might wonder why we're not putting it in the downstream step method. The reason we're not is because if you put it in downstream step, then it's going to run 4 times instead of 1. It'll run for every single repeat, and that's just extra computation that we don't want to have to do. It makes the game take longer, and when you're running thousands of episodes, making the game take longer is a problem. So we're going to return observation, player 1 reward, player 2 reward, done, truncated, info. And in most gym environments, if you're used to working with gym, you know that you just return a reward. In this case, because we're doing self-play, we actually need both. We need all of it. We're going to grab this line and run up here to our game loop. And I really just want to make sure. Yeah, I don't need that return. I really just want to make sure that if I set these things equal to self.step, let's go ahead and print out observation. I just want to make sure that we're getting what we expect to get. Yep, that looks pretty good. That looks like about what we would anticipate. Let's go ahead and I don't see any 255s. Let's just go ahead and grab the 0th element of observation. Maybe a dot sum. I want to make sure. That we're okay. Cool. Yes, we are getting non-zero numbers inside of that observation. I'm going to encourage you to go and run the same tests. Let's make sure that player 1 reward, the reward dynamics work. Yep, we occasionally see a 1 and a -1. Player 1's over here on the right. Let's go ahead and do print player 1 reward. And then we also want to do the same with player 2 reward. Okay. And we can go ahead and print out done. Okay, all of these things matter. Okay, so we can see that player 1 gets a +1 while player 2 gets a -1. And if we want to grab our main.py here and just change bot difficulty to easy, because that's going to give me a better, in fact, let's even just do if reward player 1 reward is not equal to 0. That'll clean up some of the visual noise. Okay, so for that one, player 1 scored, and yep, and we're seeing things correctly reverse, and all of our rewards are coming back successfully. So what that tells us is at this point in the series, we have a successful Pong game that can be treated like a gym environment. It's going to return rewards, dones. It is going to allow our agent to play, hopefully, and train successfully. So in the next video, we are going to go ahead and start working on the agent that will start to learn, via reinforcement learning with a basic Q-learning approach, how to play the game. Reminder, again, the code for this video will be in a GitHub tag in the video description. If you run into any issues, you can go check out the tag or join the Discord. And with that, I will see you in the next video.